So the next thing that we're gonna do is we actually need to convert the list to a vector. Yeah, TensorFlow only understands tensors, so we need to convert it to a vector, and that's the 5 line of codes that will make that happen. So we call this procedure vectorized sequences, and here you see the dimension is vocabulary. And basically the way you have to see these 5 lines of code is that you're gonna have all your reviews as a row, yeah, and then as columns you have your 7,500 vocabulary words. And whenever a word from the review is appearing in these 7,500 words, you put a 1 on that spot. Yeah, I also explained it a little bit on the whiteboard, but that's exactly what is happening. Yeah, so we can run this cell, and the next thing that we're gonna do is we're gonna vectorize the train and test data as well as the labels. Okay, let's now run this cell and convert the train and test data as well as the labels to an array. So here we applied the vectorized sequences function that we just defined previously. For the y, we use a simpler conversion. We use asArray, and asArray allows us to convert, for example, a list in our case to an array, and the type of the elements in the array will be float 32. Okay, for example, let's now see how does X train look like, and maybe we just take the first element here, and here we go. It's exactly what I mentioned. We basically, for each review now, we have 7,500 columns, and you will only find the one if the word appears in the review. For example, if we consider that there's 100 words in a review, you will have 7,400 zeros in these columns. Yeah. So let us see what the type is now. So let me just put type in here, and then put 2 here. And here we go, it says it's an array. And we could actually look at the y component as well. Here we go. Also a NumPy float 32. Yeah, so we're good to go. Now let's see. Basically, let me run all the code now, restart and run all, because we're basically done with the pre-processing task at this point. Yeah, this one very fast. Even if we include these type of commands like print and print type, we still only have roughly 10 lines of code. Okay, now we're ready to start our naive Bayes classifier. So I import naive Bayes from sklearn. Yeah. So the model we call multinomial naive Bayes. It's quite obvious that we use multinomial because it's a discrete probability distribution. So let's now fit the model and check what the accuracy is. Here we go, and we get an accuracy of 84%. That's actually quite a good accuracy. Remember, in the k-nearest neighbor algorithm on the Indians, we arrived in the 70s, in the low 70s. So here is actually quite good. So there's a few other metrics that we can look at, and basically what we're gonna do is we're gonna go back to our k-nearest neighbor coding exercise, and we're just gonna copy and paste some stuff from there.